Good morning. Today we are starting our new unit, Unit 7, and it's all about probability. So we're going to be learning about probability in this unit. So first thing PO39 is our first objective. I can determine the number of possible outcomes of an event. So I said we're learning about probability. We need to know what probability means. Probability is the likelihood of an event happening. So probability is the likelihood of an event happening. So there is a scale to probability. So the scale of probability looks like this. If it is 0%, is it going to happen? No. 0%, it is not happening. All the way to 100%, it is definitely happening. So then we've got 50% is in the middle. 25% is close to not happening. So 25% would be not likely. If it is 25% or around there, it's not likely that it's going to happen. 50%, it's a 50-50 chance. We just don't know. 75% is close to it definitely is happening. So 100% would be definitely. So 75% means it is likely going to happen. So when we're looking at those percentages, the higher percentages are more likely to happen. The lower percentages are less likely to happen. Does that part make sense? Okay, if we get all the way to 100%, it is definitely happening. So any percentage that's getting up close to 100% is more likely to happen. 0%, it is definitely not happening. So any percentages that are getting down towards that 0%, it's less likely. It's not likely to happen. So to determine how many possible outcomes there are for an event, we need to some way to figure out everything that could possibly happen. And we have two methods for doing this. Oh, we love when we have multiple methods. When we know math, we can get to the same answer doing it in different ways. So let me scroll up. There we go. So let's say that we flip a coin 3 times. How many possible outcomes are there? So we're going to look at our first method to do this. Yes? You have a guess? What's your guess? Okay. That is a good guess because flipping a coin, there's a heads and a tail. We do it 3 times. So I can see how you got 6. You did 2 times 3. Here's how we're going to do it differently because that is not quite right. We're going to learn some math. Yay. First way we're going to do it is a probability tree. Here's how we use a probability tree. We know that there are 3 times we're flipping. So we're going to say flip 1, flip 2, flip 3, and then we're going to list all of the outcomes. So for flip 1, here's our coin. For flip 1, what can our possible results be, James? Heads or tails. So that's my flip 1. Flip 2, if I flipped a heads on flip 1, what could I get for flip 2? I flipped it and I gotten heads. I'm going to pick that coin up and I am flipping it again. Heads or tails. So for flip 2, I could get heads or tails if I had gotten heads the first time. If I got tails the first time, what could I get the next time? Heads or tails. Now I'm at flip 3. I could get heads or tails. If I had flipped to tails, I could get heads or tails. If I had flipped,
I don't like this method.
I could get heads or tails.
I don't like this method.
And here, I could get heads or tails. But the beautiful thing about math, Hugo, is some people, this is going to make sense to them because we're seeing it all laid out. So your brain automatically jumped to the more mathematical way, but some of our brains need to see it to understand it. So when we want our possible outcomes, we're going to look. Heads, heads, heads. I could get 3 heads. I could get heads, tails, heads. I could have flipped to heads, then flipped to tails, and then flipped to heads.
Should we write this heads?
Well, whatever I write on the board when we're recording the lesson, you should be writing in your book. So these are all of the possible outcomes we could get. If I flipped to heads, and then I flipped to heads, I could flip a tails. If I flipped to heads, and I flipped to tails, I could flip another tail.
Okay. I don't get this.
Shh. So I could flip heads, heads, heads. I could flip heads, heads, tails. I could flip heads, tails, heads, heads, tails, tails. So that would be these ones. Heads, tails, heads, heads, tails, tails.
And then all that beginning.
Then I'm going to do the same thing, but this time I start with my tails. I could flip tails, heads, heads. I could flip tails, head, tails. I could flip tails, tails, heads. And I could flip tails, tails, tails.
8.
So we get 8 possible outcomes. Because you just follow heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. And I can see that there are 8 possible outcomes. So which part was confusing, Emily? So did you see how we did our flips? And we broke it up. Okay, so the first step you understood. It was coming up with the outcomes. So coming up with the outcomes, you go across heads, 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 tails. Tails, tails, heads. Oh, sorry.
No, wrong.
Heads, tails, heads. So heads, tails, heads. Then heads, tails, tails. So we get all 4 of those. Do you see how I got those? So then I do my tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. So you're just going across. So that is the method 1. Like I said, some of us need to see it, and we're more visual. Then I said there's a more mathy way. So let's look at the mathy way. For our second method, we have number of outcomes. We've got flip 1, flip 2, flip 3, right? How many outcomes can we get for flip 1? 2. Heads or tails. We could get 2. How many outcomes could we get for flip 2? 2. Heads or tails. How many outcomes could we get for flip 3? 2. Heads or tails. So now we're going to do 2 times 2 times 2. 2 to the 3rd power. Because why did I start with the first method?
Because some people need to see it.
Some people need to see it. And if it confused you, that's okay. There are some people in the class who need to see it. So we show that. Okay? So if we look at, we have 3 pairs of pants and 4 shirts. How many possible outcomes can you make? So the first thing we're going to do is say how many or what colors do we want them to be? So if we've got 3 pants, so for my pants, what color should I make them? Hugo, tell me a color.
Red.
What's another color, Emily? And one more color, Jonas, or Luca. Brown. Okay, now I need 4 shirt colors. Ben. Michael.
Black, because that's a good idea in summer.
Aiden.
Purple.
We're not going to duplicate colors just for ease of doing this. Tell me a color we haven't used yet.
Teal.
Teal.
Everything besides V.
Shh. Audrey. White.
I'm like.
Okay, so now for our probability tree. We're going to have, I'm just going to use the first letters except for my B's. I'll put in a little bit more. Oh, we have 2 BLs. Yeah, we'll just have to use it. Let's change a color to make it a little bit easier.
Orange.
I heard orange first, just to make it easier. Sure. So now we're going to do our probability tree to show how we map it out. So first we have our pants, then we have our shirts, then we're going to write down all the outcomes. So starting here, how many different pants colors do we have? 3. So I'm going to do 1 for the red, 1 for the purple, and 1 for the brown. Right? That's our 3 choices. It could be either red, purple, or brown. How many shirt choices do I have? 4. There's 4 shirts. We have 4 different colors. So if I have red pants on, not asking ourselves if it's going to look good, but because we might want to have a crazy silly day. So I have 4 shirt choices if I'm wearing red pants. It could be blue, it could be orange, it could be teal, it could be white. Now if I'm wearing purple pants, I again have 4 shirt choices. Blue, orange, teal, and white. And then if I have on my brown pants, I should put a BL for my blues. Brown pants, I have 4 choices. Blue, orange, teal, or white. Okay? So now I need to look at my possible outcomes. I could have red, blue. I could have red, orange. I could have red, teal. I could have red, white. So I could do red, blue, red, orange, red, teal, red, white. The conversations need to be done. Shh. Conversations are done. I am recording, and it's picking up all of our talking. We are quiet. For the purple pants, I could have purple blue, purple orange, purple, teal, purple, white. And for my brown pants, I could have brown, blue, brown, orange, brown, teal, brown, white. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 possible outcomes. I couldn't hear you, Emily. So, shh. This is the way to do it if you forget the mathy way. This is the way to do it to visually see it. Okay, you're visually seeing each outfit made. You might get a question that says, how many outfits can you make with an orange shirt? Doing it the mathy way, is that going to tell us the answer? No. So do we need to know how to do the probability tree? Yeah. You need to be able to look and say 1, 2, 3 outfits with an orange shirt. Okay. So you do need to know how to do this depending on what the question asks us. If it's just asking how many outcomes are there, then we can do it this way. For numbers of outcomes, we would have pants and shirts. We know that there are 3 pants and 4 shirts, so it's 3 times 4 equals 12. We get the same number of outcomes. The probability tree breaks it down so we can see what actual each outfit would be. So we might need to do that to answer specific questions. Emily. Mm-hmm. Probability is on the math test. Shh, it's Aiden. Okay, so while this is visual, and some of us immediately jumped, number of outcomes, I just multiply them together. We still need to know the visual way for if they have specific questions. How many outfits with an orange shirt? You might want to write it out so you can see it. Does that make sense? Either way to get the final outcomes, but we might have to do the probability tree for those specific questions.
Well, so for like the coin flip one, you have to be careful not to do 2 times 3.
Correct. And that was the mistake that somebody made at the beginning. They said, 2 times 3, but it was 2 times 2 times 2. It was going to the exponent of 3. So let's look at our word problems at the bottom. A password with 5 letters, the letters may repeat. How many possible passwords can be made? So we're going to do it the mathy way because it's asking for total outcome. How many altogether? So we have our number of outcomes. We have letter 1. Instead of writing letter out, I'm just going to put L1. Letter 2, letter 3, letter 4, and letter 5. So we have 5 letters. So I wrote L1, L2, L3, L4, and L5 because there are 5 letters in our password. So do we see why I went out to 5?
Yeah.
Okay. So now we're going to look and say how many possible letters for letter 1? Hugo.
26.
26. There are 26 letters in the alphabet. Sometimes we have to think it through a little bit. There's 26 letters in the alphabet, so there's 26 possibilities for letter 1. Our letters may repeat. So how many possible letters for letter 2? Aiden? 26. How many for letter 3? 26. How many for letter 4? 26. And how many for letter 5?
26.
How do I find my possible number? What am I going to do? Chance?
Well, are you allowed to use a calculator? But if you can, it would be 26 times 26 times 26 times 26.
We're going to multiply all of these together to get our answer. 26 to the 5th power.
Oh my gosh.
So remember, if we are going to, oh my goodness, friends. Quiet, please. If we are going to go to use that 5th power on our calculator, here's a refresher because some of us forgot. You put in the 26, then you go to your little caret button, and that gives you your exponent, and we have 5 26s, so it's 26 to the 5th power.
We don't have 5 26s.
Didn't we have 5 26s?
26 to the 5th is not 26. 26 times 5 would be 5 26.
No, 26 to the 5th power is 26. There's 5 26s times 26 times 26 times 26 times 26
I
times
thought you meant
26.
like 25,
Yeah.
26.
No, 26 to the 5th power means you have 5 26s that you're multiplying.
I thought you meant like
Yep. So then we get a big number. And you need to write that big old number down. So that would be 11,881,376. Let's go back to our page here. That was 11,881,376. It is a big number. That's a lot of password combinations. Now let's look at how many possible passwords can be made if letters cannot repeat. So I'm going to start out the same way. Number of outcomes. And I'm going to have my 5 letters. So L1, L2, L3, L4, and L5. Because I've got 5 letters. How many possible letters are there for the first outcome, for my first letter? Michael. 26. Now, the key thing to remember is that letters cannot repeat. So how many possible letters are there for letter 2, James? 25. Because whatever I chose for my first letter, I can't repeat it. So that one's out. So now we only have 25. Now we have L3, letter 3. Aiden? 24. And for letter 4, Tatum?
23.
And for letter 5? 22. So I'm going to multiply 26 times 25 times 24 times 23 times 22.
equals.
It does not equal 21. Much bigger than that. What does it equal, Aiden?
7, 8, 9, please.
7,893,600.
Not nearly as big as last.
Very different answers. It is important that we read our word problems completely. We need to read our word problems completely so we know if our letters are repeating or if they're not repeating, because we get very different math problems, very different answers. Is it a quick question, Gus?
Yeah.
Yeah.
So I saw this on the math masters. Can't you write that using something factorial?
That's going from 26 all the way down to 1. We're not going all the way down to 1.
Right. Yeah, because there's just 5.
Yeah,
So
that's not
we'll get
correct.
back to that later. I want to close off the recording. For my friends watching at home, we hope you are well and we hope to see you soon. Have a wonderful day.